Hello, Professor. My name is Zhang Qianrun, and I am honored to present my master's thesis today. The title of my research is Predicting Employee Attrition Using Machine Learning Algorithms. First, I will briefly introduce the background and goals of this research. A high employee attrition rate leads to significant replacement costs and reduced productivity for companies. We aim to use machine learning techniques on an IBM HR dataset to predict which employees are at high risk of leaving and to identify the key factors that influence attrition. This research focuses on how to effectively predict employee attrition and help companies retain talent. By building a predictive framework, we hope to identify high-risk employees in advance so that timely interventions can be made to reduce financial losses and operational risks. In addition, we analyze the main drivers of attrition, such as compensation, career development, and job satisfaction, and compare the predictive performance of different machine learning algorithms in this context. The main objectives of this study are threefold. First, to build an employee attrition prediction model based on the variables in the dataset. Second, to identify and analyze which features have the greatest impact on attrition in the model. And third, to compare multiple machine learning algorithms and select the optimal model. Through these objectives, we hope to provide companies with an accurate attrition alert tool and to enrich the research perspective on employee attrition mechanism. Regarding the methodology, we first reprocess the data, including data cleaning, outlier removal, and feature selection, and then normalize the numerical features. We split the dataset into 80% training and 20% testing, and use cross-validation to ensure robust model evaluation. We train 4 common classifiers: decision tree, random forest, logistic regression, and gradient boosting. Finally, we evaluate the models using metrics such as accuracy, recall, and F1 score to comprehensively compare the predictive power of each algorithm. Regarding data and modeling, we use the IBM HR Analytics dataset, which contains 23,436 employee records and 37 variables. Important features include age, total working years, overtime status, business travel frequency, job role, and monthly income. The target variable is whether an employee has left. In terms of model selection, we compared the predictive performance of multiple algorithms and found that the random forest model outperformed the others in accuracy, recall, and AUC. Therefore, we chose random forest as the core model. We trained and tested all 4 models and evaluated their confusion matrices and performance metrics. The results show that the random forest model performed the best on all metrics. Its accuracy and recall were significantly higher than those of other models. The comparison of the ROC curves also revealed that the random forest has the highest AUC, indicating that it has the best classification capability. These results demonstrate that random forest is the best choice for predicting employee attrition in our study. Using the feature importance evaluation from the random forest, we identify the features that have the greatest impact on attrition: age, total years of service, overtime status, business travel frequency, job role, and monthly income. Among these, age and total years of service has the highest contribution, indicating that attrition risk changes with the employee's age and tenure. Understanding these key factors helps companies develop differentiated retention strategies for different groups of employees. To present the model results and insights more intuitively, we built an interactive dashboard using Tableau. The dashboard displays information such as overall attrition rate, attrition trends by department, and the contribution of key factors through charts. Users can filter the data by department or other criteria to view the profile of high-risk employee groups. With this dashboard, managers can clearly see which groups have higher attrition risk and which factors are at play, thereby supporting targeted decision-making and intervention. This study shows that applying machine learning techniques can significantly improve the accuracy of predicting employee attrition risk, which is of great practical significance to companies. On one hand, by systematically quantifying multiple factors, we provide new insights into the mechanisms of employee attrition. On the other hand, integrating the predictive model into human resources management systems can enable early warning for employees at risk of leaving, thereby significantly reducing recruitment and training costs caused by attrition. Additionally, it should be noticed that our dataset lacks temporal and structured information, which may limit the model's generalizability. Future work could consider incorporating dynamic multiple source data and fairness techniques to further enhance the model's robustness and applicability. These studies successfully built a random forest-based model for predicting employee attrition and demonstrated its superiority. The experimental results show that the random forest model outperforms the other models in terms of prediction accuracy and recall. The study also confirmed that age, total years of service, overtime, and monthly income are key factors influencing attrition. Our model and dashboard provide companies with a tool to monitor attrition risk in real time, helping them intervene early and retain talent. We recommend that companies apply this predictive model in their daily HR management, regularly monitor employee attrition risk, and take targeted actions. Future work could incorporate dynamic data such as employee performance evaluations and satisfaction surveys, explore richer algorithms such as deep learning or ensemble methods, and address algorithmic fairness to further improve model performance and applicability. That's all. Thank you for your listening.